This is called a Hubble tuning fork diagram. A tuning fork, if you play guitar, if you play any instrument that has to be tuned, like piano, you have a tuning fork. Tuning fork has got an arm. You grab it, hold it, and this is the tuning fork. So we call this the tuning fork diagram. We have the elliptical galaxies here, and we also have the dwarf elliptical galaxies here. So two types of ellipticals. There's giant ellipticals and miniature dwarf ellipticals. We classify them as E0 when they're perfectly spherical, D, dwarf elliptical of zero kind. So they both look the same. One of them is gigantic, one of them is just tiny. Where do they come from? I'll explain that to you today, where they come from. And here's a dwarf elliptical galaxy of the fourth kind, giant elliptical galaxy of the fourth kind, like that. Now we have lenticulars. I added this. Lenticular galaxies have two types, S0 and SB0. What does that mean? S0 is a galaxy just like the normal spirals, except it doesn't have spiral arms. It's got everything else, but no spiral arms. SB0s are just like the regular S0s, except they do have a bar in the center. So we call them SB0s. Now I said here, spirals have population 1 and population 2. So lots of old and young ones live side by side. They have lots of dust and gas. Well, that's what you need to build, new stars. They have flat rotation disks of stars and a bulge in the center. Okay, they all have that in common. Same with lenticulars. They only lack the spiral arms. So everything that I said here also applies to the lenticulars. They look a lot like spiral galaxies. They just don't have spiral arms, that's all. So there you go. All of these guys here have the same exact attributes. When we look at the ellipticals have only population 2, only old stars. And a tiny star-like nuclei. Instead of big bulge, they have a tiny star-like nuclei. What could that be? Supermassive black holes, right? So they do have supermassive black holes in them, and they have no dust and gas or spiral arms. So if they have no dust and gas, that means they don't build any new stars, which explains the population 2 only stars, right? So you can just use your head and figure this out. Where would these guys come from? Now, irregulars are the ones that you can't classify. They have no nuclear bulge, nor any trace of spiral arms. The structure, basically there's no structure. They have population 1, population 2. They have dust and gas, so there is population 1, population 2. Often chaotic in appearance. So if you can't classify a galaxy, most likely they don't have nucleus. They have everything else though, that spiral galaxies, just not nucleus. What does that remind you of? We'll take a look. So we're going to see where everything came from, all these galaxies emanated from. Meanwhile, so let's go back one more time. You guys take a look at all these, because I'm going to give you some points for classifying some of these galaxies. If you see a galaxy with a big nucleus, spiral arms, very tightly wound up, SA. If you see a galaxy with a small nucleus, very open arms, SC. If you see the same, except they have this bar going through the center, SBA, SBB, SBC, like that. And if you see something weird that you can't possibly classify, irregulars. Lenticulars look a lot like these guys. They just don't have spiral arms. And these guys speak for themselves. They're just elliptical. You should be able to see right through the elliptical galaxies. All right.